So today we'll be talking about Unit 4 solving systems, and we will be discussing how to solve two different systems. So if we look at our question here, the two functions that we're trying to solve for are x minus 2 squared plus 4 and 2x plus 3. And if we look at these functions, we can automatically tell that x minus 2 squared plus 4 is going to form a parabola because, as you can see, it has a square, meaning that the graph will form a parabola. We can automatically tell that 2x plus 3 is going to form a line because it is simply nothing is happening to the x besides it being multiplied and added by 3, meaning that it's going to be a line. So there's two main ways that we can solve for the solutions to this system, and those ways are graphically and algebraically. Graphically, obviously, having to do with drawing a graph, and algebraically requires doing algebra. So we'll start with algebraically first. So for algebraically, once again, let's write down our equation. X minus 2 squared plus 4 is equal to 2x plus 3. So by solving algebraically, this essentially means using algebra to get x all by itself over to one side and being able to solve for x to find the different numerical solutions to this equation. And so the first step to this is breaking up x minus 2 squared into x minus 2 and x minus 2. And this is just going to make this problem easier to deal with because we won't have to be dealing with that square. We'll just be dealing with all x's. So let's carry everything else down. And so from here, what we have to do is use the FOIL method to combine x minus 2 and x minus 2 into a polynomial. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is also negative 2x, and negative 2 times negative 2 is positive 4. Meaning, so we'll write down all these numbers we got, and once we get these, we'll combine the like terms of negative 2x and negative 2x to form negative 4x, and we'll have x squared minus 4x plus 4, and we'll carry down the stuff that we have up here. Plus 4 is equal to 2x plus 3, and we'll bring it down. So now let's go ahead and combine like terms. So we've got a 4 and a 4, and these are both don't have any x's by them, so we can combine them. So this will be x squared minus 4x plus 8 is equal to 2x plus 3. And next, let's move the 3 over to the other side. So let's combine that 3 with the 8. So we'll do minus 3 to both sides, and we'll get x squared minus 4x plus 5 is equal to 2x. So from here, once again, we have to get all the x's over to one side, and we're going to try to get this equal to 0. So what we're going to do is subtract 2x from both sides in order to get x squared minus 6x plus 5. So as you can see, this now forms a polynomial that is equal to 0. And what we can do with this now is we can use the factoring method known as the x box in order to find out the different solutions for this. So to create the x box, you make an x, and on the top you write the number you get on the top. You get that number by taking a, or the first number, which is 1, and multiplying it by the last number, or c, which is 5. And for the bottom number, you take the middle number, or b, which is negative 6, and put that on the bottom. So the way this table works is that you have to find two numbers that when multiplied together equal the top number, but when added together equal the bottom. So in the case of 5 and negative 6, those two numbers would be negative 1 and negative 5, since negative 1 times negative 5 equals positive 5, while when they're added together, they'll combine to form negative 6. So now that we've got these two answers, we know that our solution to this is now x minus 1 and x minus 5. And since this is equal to 0, we have to find the number that when we plug into x makes it 0. So obviously 1 minus 1 is 0, and 5 minus 5 is 0. So our x's will be 1 and 5. So with these x's, we're not done yet. We have to plug them back into our equation in order to find out what the y is. So I'll be plugging this into the linear equation 2x plus 3 just because it's simpler, and I won't have to do any squaring. So let's plug in 2 into this equation, so we'll get 2 times 1, which is 2, plus 3 is equal to 5, so that's our y for 1. And for 5, we'll get 2 times 5 plus 3. 2 times 5 is 10, and if we add 3 to that, we'll get 13, meaning that our xy coordinates for this are 1 and 5 and 13, and these are our final answers for this. So we'll see how these points relate to the graph when we solve this graphically, which is what we're going to do next. So I have our points here, and I've rewritten our two equations, x minus 2 squared plus 4 and 2x plus 3. So solving graphically means that we graph these points on this line, graph these points on this table, and we see the points where they intersect to see where the solutions to the graphs are. So if we take a look at these equations, we'll see that our first one is written in AHK form, which is ax minus h squared plus k, while our second and our line is written in y equals mx plus b form. And this makes it very easy to graph, because in x minus h squared plus k, if our formula is in ah and k form, we automatically know whether or not the graph is going to be facing upward or downwards, depending on whether a is positive or not. We'll know how far it will be shifted to the left or right through h, and we'll know how far it will be shifted up or down through k. So if we take a look at our first equation, I'll graph it in purple. If we take a look at our first one, we will see that if we start at 0, 0, and we go, and since we have since our h is equal to positive 2, we'll go 2 to the right, and since our k is positive 4, we'll go 2 up to make a point at 2, 4. And now, in order to graph a parabola, you need 3 points. So a trick that I use for finding the other 3 points, or just for finding the other 2 initial points, is by looking at the a. And since our a in this case, we can't see it, meaning that our a is 1, an easy way to find the next 2 points is simply by taking our first point, or our vertex, and going up 1 over 1 on either side. So I'll do that on either side. And just regarding the tip I told you about going up 1 over 1, if the a is any other number, such as 2, 3, 4, you would do the same thing. You go up 3 over 1, if the a was 3, or up 4 over 1 if a was 4. So it would be the same thing for that. So now that we've got our 3 points, we can graph our parabola, and that is our graph of x minus 2 squared plus 4. So now let's graph 2x plus 3. And this is written in, like I said, this is written in y equals mx plus b form. M is standing for the slope, and b is standing for the y-intercept. So since we know that 3 is the y-intercept, since it's b, let's go ahead and make a point at 0, 3, which is the location of its y-intercept. And since we know the slope, which is 2x, or 2 over 1, we know that we have to do up 2 over 1 for each of our points. So let's do up 2 over 1 to the right, and down 2 over 1 to the left in order to get 3 points, so we can just connect the line through. So now once we connect this line, let's take a look at where the line crosses with the parabola. So if you take a look, it happens to intersect in the exact same places we calculated, 1, 5, and up top it intersects at 5, 13. And this proves that the points that we solved for earlier are the correct solutions, because these are the places where these intersect, which is why these solutions can also be called the points of intersection of this system. So that's how you would solve this problem. And a real-world example this can be applied to is the occupation of air traffic control. And air traffic controllers who work at airports, they essentially have to look at screens that dictate all the different paths that airplanes are taking in the sky, and they have to make sure that none of these airplanes collide. And they do this by looking at all their paths and seeing where they intersect, and making sure that the speeds are going just right so that they won't collide with any other planes. So they have to understand the idea of points of intersection. So that concludes today's lesson. Just a recap of what we've managed to do. We've managed to solve an equation. We'd managed to solve for a system of equations one that was a formed parabola, one that was a quadratic function, the other was a linear function. We were able to solve it both algebraically and find the numbers, and also be able to graph it and find the points of intersection. So that concludes today's lesson. Thank you for watching.